following worksheet is 3.4 from the mathematicsvisionproject.org. And I just want to go through 13 through 20. And before I do so, I want to review some laws with you. These are some laws. There are 8 laws of exponents. I'm going to review 4 of those. One of our laws says that if I have a times b to the power of c, this can be expanded to be a to the power of c times b to the power of c. Another law that we're going to use for the following worksheet is if I have a to the power of b to the power of c, then that we are going to multiply our exponents to get a to the power of b times c. The third law that we're going to use for these problems is our rational to radical rule, where if I have the cth root of a to the power of b, I can rewrite this as a to the power of b to the power of 1/7, which would be a to the power of b over c. So these are the laws that I'm going to need for this particular worksheet. Now let's look at the first one. Our first problem here says we're going to go from radical form. So I have the cubed root of 5 squared. Well, with this particular problem, all I need to do is this last rule, where I'm going to rewrite this as 5 to the power of 2 times 1/3. Then that means we're going to, in this case, we are going to use the second law that I introduced you to. We're going to multiply. That gives us 5 to the power of 2/3. The next one, well, at this point I need to move back to our radical form. So I'm going to rewrite this as 16 in the fourth. Well, let me do this in pieces. So this is going to be 16 to the power of 3 to the power of 1/4. So our root is 4. The denominator is always going to be our root. I can rewrite this then as the 4th root of 16 to the power of 3. So I'm thinking that maybe I could break this down a little bit more. So 16 I could rewrite as, let's do a factor tree for the 16. So I have 16 could be broken down into, well, 4 times 4. And 4 can be broken down to 2 times 2, as well as this other 4. That gives me 2 times 2 times 2 times 2 gives me 16. So I'm going to rewrite this as the 4th root of 2 to the power of 4 to the power of 3. Again, I'm going to use that second law. I'm going to multiply those. It gives me the 4th root of 2 to the power of, we're going to multiply to get 12. And there you go. So let's move on to the next one. I'm going the other direction. I'm going to go from radicals to rational exponents. So I'm going to rewrite this as 5 to the power of 7 times 3 to the power of 5 times all of this. We're going to multiply by, this is our third law. This becomes 1/3. We use our second law. This is actually a combination of the first and second law, where this c, if we're multiplying in the parentheses, then that c belongs to the a and the b. And when we distribute that c belongs to our, we're going to be multiplying when we distribute it. So this is going to give me then, this is going to give me 5 to the power of 7/3 times 3 to the power of 5/3. Here I'm going to rewrite, so there you go. This is now in rational form. I'm going to rewrite this problem, as 9 to the power of 2 times 9 to the power of 4, and all of this is to the power of 1/3. So our radical is a cubed root, so I have a cubed root of 9 squared times 9 to the power of 4. Now, if you're so compelled, we could also rewrite this 9 as, in a factor tree, 9 is 3 times 3. So I could rewrite these 9s as, so I have the cubed root of 3 squared times 3 squared to the power of 4. And then all this becomes, we can use our second law where we multiply. So I get the cubed root, sorry, all this is cubed root, all this is. So that gives me the cubed root of 3 to the power of 4, we're multiplying, times 3 to the power of 8. Now I guess there's one other law I did not bring up. This is the most elemental law, is that if I have, this is our fourth law then, of exponents, if I have a to the power of b times a to the power of c, we are going to add the exponents. That would give me a to the power of b plus c. So we could just add these then to get the cubed root of 3 to the power of 4 plus 8. That is going to give me 12. So there you go. Suppose that could have even simplified down to like 3 to the power of 4, but we're not, that wouldn't give us a radical then. So here we go, we have the cubed root of 3 to the power of 12. Right, let's look at the next one. So I'm going to write from our radical form to a rational form. I'm going to rewrite this as x to the power of 13 times y to the power of 21 to the power of 1/5. So then we're going to multiply. We have x to the power of 13 fifths times y to the power of 21 fifths, and we are done. Next one, same thing. We are going to rewrite this as 27, which is 27 to the power of 1, times a to the power of 5, times b to the power of 2, and all of this to the power of 1/3. Now we multiply our exponents, we get 27, we have 1 to the power, 1 times 1/3 gives us 1/3, and I have a to the power of 5/3 and b to the power of 2/3. Now I would imagine that I can break this down even further. We could do a factor tree for the 27, and we get 9 times 3 or 3 times 3. So the 27 can be rewritten as 3 to the power of 3 to the power of 1/3, which is, when we multiply, we get 3/3, 3 to the power of 3/3, or just 3. So we could rewrite all this as 3 times a to the power of 5/3 times b to the power of 2/3, and we are finished. Right, the next one, I have this fifth root, and we're going to rewrite this again into our rational functions. So I'm going to rewrite this as 32x to the power of 13 over 243 y to the power of 15, all of this raised to the power of 1/5. So that 1/5 belongs to all these components in here. That gives me 32 to the power of 1/5 times x to the power of 13 fifths over 243 to the power, this is 243 to the power of 1, so we're going to multiply to get 243 to the power of 1/5, and then y to the power of 15 fifths. Now if we want to clean this up, well, 32 using a factor tree, 32 gives me 2 times 16, or 4 times 4, or 2 times 2, and 2 times 2. So 32 is the same thing as 2 to the power of 1, 2, 3, 4, 5, 2 to the power of 5. So I'm going to rewrite this as 2 to the power of 5, but this is 2 to the power of 5 to the power of 1/5. So that's going to give me 5 times 1/5 is just going to give me 1. So I think that would be helpful to write this out. This 32 to the power of 1/5 can be rewritten as 2 to the power of 5. So 2 to the power of 5 times 1/5, and that gives me 2 to the power of 5/5, which is just 2. So I can rewrite this 32 to the power of 1/5 as just 2. And I still have this x to the power of 13 fifths. And then I have this 243. Well, let's break down the 243. 243, that is going to give me 243 divided by 3, it's going to give me 81. And then 81 is 9 times 9, and 9, of course, is 3 times 3. So this 243 can be rewritten as 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or 3 to the power of 5. So again, I have this 243 to the power of 1/5 can be rewritten as 3 to the power of 5, 3 to the power of 5 to the power of 1/5. And 5 times 1/5 is going to give me 3. So I have 3 times y to the power of 15/5, and 15/5 is just 3. So there we go. The last one. Well, if we look at this particular problem, you can see that the denominators are all different. Well, at least the denominator for the 2 and for the 9, my exponent is different than compared to the exponent for s. So I'm going to rewrite this so that all of my denominators are going to be the same. So I'm going to multiply by 1 in the form of 3/3. So I have 9 times 3/2, and I'm going to multiply then by 1 in the form of 3/3. And then s times 6/3, I'm going to multiply 1 in the form of 2/2. And then I have t to the power of 1/2, and I'm going to multiply this 1/2 by 1 in the form of 3/3. So that's going to give me, I have 9 to the power of 9/6, s to the power of 12/6, and t to the power of 3/6. So I can rewrite this then as 9 to the power of 9 times s to the power of 12 times t to the power of 3 to the power of 1/6. So my root then is 1/6, or is the 6th root of 9 to the power of 9 times s to the power of 12 times t to the power of 3. Now I can see that I could do one more thing. This 9 again is 3 times 3, which is 9. So I could rewrite this as 3 squared to the power of 9. I'm going to write everything else the same. And then power to the power we multiply, so that gives us the 6th root of, well, that's going to be 3 to the power of 2 times 9, which is 18, times s to the power of 12, times t to the power of 3. And there you go. I hope this was helpful. Have a wonderful day.